Morning, Noah. Uh, oh, not what I wanted. Okay. All right. So hopefully you can hear me. We can get underway. So no, that's not this morning. It feels like that sort of picture this morning in some respects. It's really gray, overcast here, and it's cold still. I'm still frozen. And Dora and I didn't get out for a walk this morning. So I sort of took an old picture that was sort of an overcast day as well, but it's nonetheless calming one. This is the Northwest Arm in Halifax, down near the Armdale Yacht Club. If you don't know where that is, if you know the Armdale Roundabout, that's the head of the Northwest Arm. And this is in a little park that's between Roundabout and the Armdale Yacht Club, Dead Man's Island, Melville Cove area. And back in the fall when there were still boats in the water, and I think that was a duck coming into land, or there's a heron that usually hangs out around that sort of spot. Likes to sit on top of moorings and markers and that sort of thing, spread its wings. Uh, but it was a nice morning back in the fall, just sort of gloomy. All right, where are we to get going? A few updates. I don't have all this written out for you. That So assignment one, uh, generally scanning the grades quickly. I haven't really looked into it carefully. The My markers were really good about getting everything marked by yesterday, and the grades look to be generally quite good. Um, Probably better than 75%, though I didn't look at the average. Uh, we're missing a few. I know I've corresponded with students on that, and they've emailed me their solutions in. There were different issues that arose. But if you didn't get yours in at all and haven't contacted me, send me a note. I may be following up with you if I don't hear from you. And the same thing happened with Quiz 4. We're still getting people that miss a quiz. Every Saturday, you got a quiz due because we have a chapter every week, and there's a quiz associated with every chapter. And so I'll be looking into that as well. Um, that There were a couple of strange cases with assignment one. I think it's in this class. I've got a couple of students that went and answered the question. Yeah, Catherine, you're one of them. You answered the fall assignment. um, that you didn't answer the winter one. I'm not sure how you brought up the wrong assignment to mark, but we'll correspond after class on that. But you weren't the only one that did that. I'm not sure how that mix-up arose. Um, and uh, okay, I'm not sure. Anyway, there was confusion, at least with two or three students, and we'll follow up on that. We'll fix the grade. Don't worry about it. Um, there were a couple that I know at least one that emailed me um, that there was they're quite concerned about their grade and what went on there, and that what I did last term, and I'm going to do again this term. The solutions are posted. You're welcome to go look through those if you didn't do well, and or if you did do well. And there's video solutions, which was an idea from last term. That uh, after going through that, if you realize, oh, now I understand, I just didn't understand it before, uh, is there anything I can do about my grade? What I offered students last term in those instances was to go revise their assignment and resubmit it to me, and I'd average the grades between their original and their revised version. And so you could make up 50% of grades that you lost. The intent, I'm not so concerned about the grade, it's the learning that takes place, and having you go and rework some of those questions helps reinforce whether or not you understand what you're doing, and that's more important to me. So if you're disappointed with your grade on any assignment, it doesn't apply to tests, but it does to assignments. If you're disappointed on your grade on an assignment, I generally allow students to do a revise, resubmit, and we'll close the gap on points that you lost. Can't get all the points back, but you'll get at least half of those points back, or you should be able to get half of them back. The only caveat there, I had students last term that copy and pasted my solutions into their paper and resubmitted it. No, you can't do that. So word questions, that sort of thing. If you understand it now, got to be your words, not my words. And okay. What else is there? Test number 2 is coming up on Friday. That last term students found test 2 quite challenging. Part of it is because of Excel questions. You might have found quiz 4 more challenging. Some of the quizzes coming up are going to be, yeah, Chris, you forgot to answer a question. Yes, you can revise and resubmit. And some students miss some things. So there are ways to close up gaps that you've got on the assignment. Don't worry about that. The some of you may have found quiz 4 more demanding. It's those Excel things were awkward to answer about pivots. And so don't be surprised. Test 2 will be probably more challenging than test 1. It's not just memorization of jargon. And that will arise on a number of the future tests. Some of them aren't that bad. They're sort of like, okay, just terminology and basic concepts. But others, particularly as they get into analyzing stuff, will be things. In your case, Catherine, I'm going to go back through yours because you're suggesting you did last term's assignment questions using this winter's data, which might be good. Okay, there's some things that would have been awkward within that, but we'll go through that after class. Don't worry about your grade. I'm sure we'll find a way of addressing that. The but grades right now are really, really high. I'm not making any efforts to try to press your grades down, but I just giving you the heads up that the material that follows is probably a little bit more challenging than the stuff we've had. I'm still anticipating very, very high grades. So far, you're doing excellent. I can't complain one bit. Definitely far better than the old 1206 calculus type of course. Your grades are a lot better than we ever saw in that course. And that seems to apply to almost everybody, which is good. The assignment 2 I'm working on in the moment, and it should be rolling out this week. And a lot of it's patterned off of last term as well. There'll be some similarities anyway. But for those students that want practice questions, I'll do what I did with assignment 1. I will post a folder that'll contain material from the fall term assignment 2. And I'm not sure if the video solutions, new thing to try, were of any help in understanding how to do some things, because I'll have to prepare videos on the solutions to last fall's assignment. But if that stuff is turning out to be useful, I'll prepare more of those. Assignment 1, I posted the solutions just about 20 minutes ago. And so there is the marking key that the markers work from. And there's a pair of videos on questions 1 to 4 and questions 5 to 8 as to how I did them in Excel, and some commentary about the word questions or commentary type questions. And but I would like feedback on that. I'm trying to figure out different things for you with this course being forced to deliver a course in a very different medium has already forced me to completely redesign the way I teach. And so breaking it up into these 12 chunks that you've got your course, the whole setup with these quizzes, tests, assignments are very different from the way I would have taught previously. And it's finding these supplementary things that maybe the technology allows us to use that we hadn't thought of with face-to-face classes. And so if you do have suggestions or ideas, I'm quite receptive to this. This is a learning experience for me. I like to learn. Um, I get tired of doing the same old thing. But the ideas I get are generally not mine. They're students either gave me an idea or they posed a challenge to me and forced me to find a way to respond to that challenge. So let's get going for today. So we're still on pivot tables, but these are, I find, harder ones. So where are we? Oh yeah, I posted a new discussion question. It's sort of similar to the last one because it's sort of like cause and effect type things. But just a few comments on it. Uh, it's not unusual for the media to report, oh, now it's eating, you name it. Pizza is not good for your health. People that eat pizza more than so many times per week or per month seem to have a higher incidence of something or other disease. Uh, every food, if you discover a new food that you really like, chances are within 6 months, someone's going to come out with a study saying, yeah, it's bad for you. I'm not sure if there's anything that's healthy for us to eat anymore. Why? Everything is unhealthy? Well, I want you to think about this is a causal one and correlation one, and that stuff we're getting into. Definitely correlation in the next class. But I want you to step back to the data understanding stage. Where do you get the data? Think about if you wanted to do a study on the relationship between eating whatever it is you like to eat, your favorite food, and some type of health impact, positive or negative health impact. How would you do the study so that you could be reasonably confident that your conclusions were valid, that the correlation, if you saw a correlation, it was true? And it's amazing how hard it is to do dietary research. Think of experiments versus observational studies and how you do each and the strengths and weaknesses of each. You'll probably find that it's almost impossible to do good dietary research. Um, not to say it shouldn't be done, but it's a lot of what's done um, is not good scientific research in the sense that I don't think their conclusions necessarily stand up to um, rigorous evaluation. Anyway, oh yes, and test two. It's so hard to make up the questions. I can't come up with enough to give you a sample. Sorry. Um, and that's going to be the case with future tests as well. It's really hard to make up multiple choice questions. If you've got a course that uses a lot of multiple choice, because they've got a textbook that's got a test bank of a whole bunch of generally awful questions that they've pulled from. For you, each of your questions are ones I'm making up. Hard on the brain. So quickly run through last class. Told you about how to make a pivot table, how to pick the rows in the table, columns in the table, how to format what's in the middle of it, how to filter cases out that you don't want, making the table, you want it not just visually appealing, but easy to read, that when you look at it, you can interpret it really quickly. You don't have to stare at it for ages. That usually means deleting things that aren't important. Get rid of the garbage, the clutter. Group things. It's hard to look at too many categories at once. Uh, it's like me grocery shopping. If I have to pick up more than 3 items, I forget. I need a list. A lot of us can't process more than three things at once. So I like tables that have generally no more than 3 rows or 3 columns. Keep it compact as long as it doesn't hide something that's really important. If some of your categories are of a sort of an ordinal nature, there's a sequence to them, reorder them so that it may be the most important item at the top and the least important at the bottom, because that's where your eye goes. You put the most important thing either at the very top or at the very bottom, because people's eyes are drawn to the extremes. But if it's an ordinal variable like very satisfied, satisfied, neutral, dissatisfied, very dissatisfied, make sure the labels are in that sequence, because you don't want them all mixed up. Makes it confusing. Be careful with a table or any type of summary. Anything you calculate from data is an estimate. It's not precise. So if it was off by 5 or 10%, probably not important. It's big differences that are really important to you. Those are actionable things. So don't read too much into small differences or numbers that come from small samples. And when you subdivide your data, filter it too much, you're zooming right in. But if you know take a digital picture and zoom in on something, as you zoom in, the quality gets worse. It gets fuzzy. Yeah, same thing with your data. As you zoom in too deeply, if you're trying to look at tiny groups, they're tiny groups, and the image is not very accurate, and you're going to make mistakes. So be very careful about that. So there are 2 things I want to do. One is an alternative to histograms, because I don't like the stats function, the histogram function. And we can do that with a pivot table. And the other, which is probably more important, is looking at what I'd call categorical variables, where I'm not finding averages. I'm looking at how many people fit into different categories. And that is a very frequent activity that we perform. So first off, to go back, remember a histogram had to do with frequency distributions. And with categorical variables, we sort of did that, I think, that we got different categories and we're looking at how many fit into each of them. And then with numeric variables, we form groups of values and how many fit in each one. And with a histogram that was hard to do, we did it, or I did it manually when I had grouped salary expectations into different categories, and I counted up how many fit into each one. And that was a way of trying to summarize a pattern that was there. It's a lot of work, but pivot tables can do it for us quickly. So frequencies, I'd use the count function, and I've got that group function that we had last time, and I'll be using it a lot today, to go and group my data together into different categories. And I'm going to be using I've reposted the data set that we're using because it keeps changing as we work through. So this is the day 8 data set. So what I did, and I'll go into Excel in a minute and do this, but a lot of it's described in the slides. I don't necessarily have to jump to Excel each time to show you, but I will periodically. If I take the variable any job, this was a question asking the students about how concerned they are about finding any job when they graduate. And they've got a big student loan to pay off, so they'd like to have a job to help pay it off. And so there were 811 students, and if you brought it into the pivot table, you would get this table, this chart. Let me just go and do that. So this is that data set. I went and I took the variable any job, I dragged it to the rows and you can see it sorted them in alphabetical order, neutral up to very, and then the special character for not applicable. And I counted how many. And when I'm counting something, I'll use something like ID, a variable that I've got a value for everybody. and I've got to change this summary to count. So let me go to value field settings and change it to count. Okay. And make it bigger so we can see. Whoops. Where am I here? And I suggested to you last class, because most of us are visual learners, to go up to the Analyze tab up here. And if you're in a table, you'll have these two pivot table tools up here, one called Analyze, and there's a thing called Pivot Chart. Click it, suggests one, grab it. It'll generally start out suggesting a column chart. So I'm just going to hide this for a second so I can show it to you. Everything in one place. So here's my table of values, and here's it visually in a chart. I don't know what it tells me. It doesn't seem to be very interesting here for a variety of reasons. Primarily, though, because I've got it poorly formatted to understand it. There are different things I've got here. I've got garbage, not sure, not applicable. I don't need those. Get rid of the junk. Okay, so those are distractions to me. That with these categories, they're not in order. I want us to go from not concerned at all to very concerned. So I'm going to move things around. I'm going to take this, I'm going to move it to the beginning, and then I'm going to take this one and I'm going to move it to the beginning. And there, now I'm going from not concerned, somewhat, neutral. Whoops, sorry, I've got the wrong way around. This one should be up here. I moved the wrong one. Move it up. And I guess I got to move this guy down. Maybe that was what I should have done. And let's get this neutral guy moved up. There we go. Not concerned at all. Somewhat unconcerned. Neutral, somewhat concerned, and very concerned. The other problem is looking at the picture, it's fine. If I was looking at the table, how do I interpret 162 or 101 or 221? I should probably change these to a standard scale, and that would be changing them to percentages. So let me go back here, and I need that list back again. I'm going to click on this one, value field settings, show values as the percentage of the column total. Okay. And now it's all percentages. If I really wanted to fuss, I would have done this, because I find that too busy. These are percentages. I get rid of my decimals. It doesn't change my picture at all over here. It's changed the vertical scale, but we weren't paying attention to that anyway. But over here, it simplifies the number presentation. And so again, what I try to emphasize, keep it as simple as possible. It's easier to read. That don't make things complicated when they don't have to be. So what did my slide say I should be doing? Did I do what I was supposed to? Yep, I changed it. The percentages, this was the picture I had. Got them in the right order. Great. Here I showed decimals. Yeah, typically I'll remove decimals. It doesn't generally tell me much. That if I said I've got two types of respondents. Some might think that I've got a bunch here and I've got a bunch here. I've got one group of graduates or students aren't worried at all, and I got another group that are very worried, and I've got smaller people that are in the middle. So first glance, these are fairly large samples. I do seem to have a certain amount of polarization, which might be something important to look at. Um, it may be I don't have a homogeneous group of students. I've got two types of students. And I might want to go and find out who are the very, very concerned ones. And why are these ones not concerned? How do they differ from each other? If they were mounded, if there was sort of a peak that went up and down again, I'd just say there's variability. This suggests that they're two different groups. So the picture is helpful there in pointing that out. But when we did histograms, this sort of looked like a histogram, but it's for categorical data. But what do we do with numeric data? So what if I put salary in my rows box? So let me go back here. So I had any job. What happens if I put a numeric variable in there? Here's salary. And you'll see all these values. Because I removed the decimals, you're seeing a whole bunch of zeros. That's just because it's, here, I can give you the decimals back again just so you can see these tiny numbers. Oops, sorry, no, it's under number format. I had percentage, and let me give you two decimals. Here we go. See, these little tiny guys. These are probably just one person, 0.12%. And there's tiny, 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 tiny numbers. And then I get some that are bigger, like 3% and 7% and so on. Look at my picture, my graph here. And you'll notice that the scale, even the highest occurring value, that was the 50,000, is only at about 15% of the observations. This is a sort of useless picture here because it's just noisy. Spike at the very end, what's that one? Whoops, blanks. 7% were blanks. So I probably don't want them. So how can I fix this sort of thing? Well, what we could do, I'll get rid of my blanks because I don't want them. Okay, still no better. I could go and, like before, I group values, and maybe I can do grouping. So I'll take a whole bunch together and create a group, a bunch form a group. But this is neat. Just grab one of them and right click. And it says I can group a single value. This is the 2000. Hit group. Whoa, what's it got here? I don't know if you can see this very well. Move it out here. It says starting at a certain value and ending at a certain value. So it's starting at 0 and going to 650,000. That was our smallest and largest numbers. And how big a jump? Maybe I want to start at 20,000. And I'm going to end at 120,000. That was the way we did our histogram. And we had increments, I think, of 10,000. Okay, what am I going to do? Boom. Okay, this is interesting. I've got ranges 20 to almost 30, 30 to almost 40, 40 to almost 50. Um, um, so it's going from these various starting values, sort of like what a histogram was doing. It gives me both ends of the range in my table. I told it I only wanted to start at 20,000. I wanted to end at 120, but actually it creates a group at the very beginning and one at the very end that describes these in groups and tells me how many are in them. And there's actually quite a few in the first one. Um, and so maybe, let me just, I'm going to go and back here. Maybe that first one is so big I should include part of it. I'll start at 10,000. There's still a lot. These are probably all the zeros, blanks, that type of thing. Maybe that's what's happening. But I don't really want to show them at the moment, but these are probably a different group. These are the students that gave me essentially a value of 0, or they didn't give me a value at all. Okay? And so we'll take them out. They're closer to having a proper histogram. And here are my relative frequencies. This is a percentage of ones that fit into each of these groups. So this is a really neat tool to be able to pull all of that type of stuff together. And it was a lot simpler than using the histogram function. It does force me to have all the bins being the same size, but it's good. I can go and do like I did with a histogram and get rid of the gaps if I want to. If you really want to do that, do it. And so I get this sort of thing, this sort of picture. But this is a lot easier to do than what we did previously with histogram. And it's got other tricks associated with it too. Let me make sure I'm on track with my slides. So there, that was what I did. And I did grouping. And sometimes you get an error message. Excel, I know you got frustrated with assignment 1. You're going to get us possibly frustrated with future assignments as well. And sometimes it's inconsistent. With the histogram function, many of you got really bizarre histograms. You didn't make a mistake. It's something strange inside Excel that's happening. In doing the sorts, uh, the different instructors in the course were getting different answers. I actually have 2 different answers in my marking key. If you look at the printed version of my solutions, it has one screen image for the sort. But if you see the video I do, it has a different one. And it's because it sorted blanks differently. It sometimes put blanks at the beginning, sometimes put blanks all at the end. I don't know why. I haven't figured it out. So here I did my grouping, and I got my stuff here like this, like I had before. And um, I closed the gaps, made it like that. Okay. Uh, Helpful to put a title on it. Generally put a title on your charts to say what it's about. Okay. What I want to do now is go and do comparisons among groups. So let me get my field list back here again. When we did histograms, a thing, I'm not sure if I showed you how to do it or just talked about it. Suppose I wanted to look at different programs. How do arts compare to business, compare to science? I could drag that to columns. Oh, busy, 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 busy. Let me, I'm going to hide this from us. Arts, business, invalid, science, not applicable. Ooh, I'll take out the ones I don't want. Okay. And there I can look at the pattern among them. It's a little bit busy to understand, in part because what I've got are clusters. I've got a cluster of 20 to 30,000, a cluster of 30 to 40, of 40 to 50. And within each cluster, I'm looking at arts, business, and science. But it's hard to see from one cluster to the next. And that's because I took away the gaps. How about if I go back? I'm going to put it back in. So it's not a proper histogram. Let's say I put in, I don't know, 150%. Put in a number. Matter. Now you see a cluster for each one. So I can look at the arts pattern more clearly, look at my business pattern, look at my science pattern. Yeah, I've got gaps in here, but I'm just looking at how the shape changes one to the next. And so I can easily see that arts students tend to have, they expect lower types of rates of pay. Science students expect really high rates of pay, and business are sort of in the middle between the two. And it makes it easier for the comparison. Like we had before, watch out for your units. Make sure that your units are appropriate. So back here with my values here, and I asked it to show values as percentage of the column total. And suppose I said no calculation. That Move this over so you can see my table as well. So you see in my table, I've got frequency counts here, and my chart as well is frequency counts. And the first group is arts, and the second one is business. And both of those I've got a lot of. So you see the blue and the orange columns are very big. You see the gray columns for science ones are very small. But that's because I only have 113 science students. This is part of a segue into our next topic. If I'm trying to make comparisons of how many fit into different categories, now these are salary categories, but they could be other types of categories. Comparing across groups and seeing how the categories fit, I need to have comparable scale. And frequencies are not a comparable scale, because these here 12 people out of 260. Whereas over here, I've got like 10 or 14 out of 113. This 10 is really bigger than that 12 because 113 is such a small number compared to 260. And I don't want to do all that mental arithmetic. By converting it to percentages, each of the numbers are in the same scale. Let's see, can I do a value? See, if I click on a number, I might be able to do the value field settings right here. I don't always do it this way. I like to do it in my fields list, but I think I can do it in the middle of the table. There I did it in the middle of the table. So I was saying before, this number here was 12, I think it was. There was one over there anyway, out of 200 260. And we had one way over here that looked like a 12, but it was out of 113. And you'll see that the numbers are very, very different. They're scaled to comparable things because they're percentages. Am I off topic? So, there I showed there, watch out. So make sure you've got the right scale. And so I'm going to get into frequency data now and look at it, frequency data in that same sort of fashion and make sure I've got the right scale. And the right scale will depend upon what the question is. It becomes trickier. These tables, here's one here where I've got the level of concern about finding any job, whether you're arts, business, or science, and I've got the frequency counts. So I've got 724 students. It's a busy table. I've got junk in here. It's not ordered properly. I've got to do those types of cleanups. So I can go and do that. And so here's some cleanup. I took out the stuff I didn't want. I got the labels in the right order. And so now I've got frequencies in the middle. Okay. What's there? Is there a pattern here? Is there anything important in here? It's tidier. It's a little smaller. To decide is anything here, I need to know what your question is. What are you asking? That, for example, are you asking whether or not art students have more concern about finding a job than business students do? That might be reasonable. That business is a much more vocationally structured program than programs in arts generally. So maybe art students might be more concerned. That I'm looking at the level of concern by program. So it's like looking at salary by program. Okay? Program is the key thing that's there. And I said before I should be adjusting things to make them percentages so I get comparable scales. But I can get different percentages. Remember, in Excel, I can look at percentage of grand total, of column total, of row total. If I'm comparing arts to business, I'm suggesting here I should be looking at columns. Let's go and look at Excel. So let me put you out of the way here. So in this one here, where's my field list? Put it back. I'm getting rid of this guy. And I'm looking at concern about any job. It's still cleaned up from before. Let me just, oh, a second here. I just noted I could do this quickly. I'm gonna do just what I had a second ago in my slide with no calculation. Okay, this is what was there previously. And there was a chart to go with it that I'm not sure what that's telling me. Okay? Is that going to stay here or run away? There we go. What's that telling me? I know the columns for science are short because there aren't that many science students. When I go to, oops, get out of my way, that with my value field settings, I could change it to a percentage. And I want to show values. Oh, wow, I can do it quickly this way here. Show values as before we compared programs by looking at percentage of column total. So let's do it that way. And if you don't mind, I am going to, doesn't give me number format. Number format. Oh, wow. Okay. Get my decimals if you don't mind. Okay. And there's a picture over here of that. Okay. So we're seeing arts being a little bit more unconcerned and science being more concerned and business seeming in the middle. Not a big pattern, maybe not a big story to this. But how did we make that choice? Why not flip it around and make it percentage of row total? What would that be showing me? Because I've got different choices. So if I went and changed that, show values as, I'm going to look at percentage of row total. Okay, so it adds up to 100% going across. What does this mean across here? Of the not concerned at all, the people that aren't worried about finding any job, not worried at all, that most of them are, well, 41% are in arts and 43% are in business. Only 17% are in science. So there aren't that many science students that are very concerned. But this pattern applies everywhere. If I looked at those that were very concerned, most of them are in arts or in business, and very few are in science. I get this picture here. Science always has little tiny columns. Science students don't care? No, we asked the wrong question, or we formatted the data the wrong way around. We just don't have many science students. So if I'm looking at any level of concern, and I look at that level, I'm probably not going to have many science students in there because there just aren't many science students. It was the wrong question to ask. I had it flipped around the wrong way. We're not going to dwell too heavily on this. We're going to pound away on this a lot later in the course when we hit probability, because these are what are called conditional probabilities. And there's a huge difference, all the difference in the world between asking among those that are not concerned, what percentage are in arts, and the question, where am I? So I just showed you among those that are not concerned, what percentage are in arts, or among students in arts, what percentage are not concerned. Different question, and sound similar, but they're very, very different questions. So anyway, this is the one I had before. It was a busy table. I got rid of the gap so I could see the clusters better. and I'm not sure if there's really much story in it. When I flipped it round the other way, I ran into this problem because there just aren't a lot of science students. So we need to know, which one are we interested in? Is it percentage of column total or percentage of row total? Depends about what you want to compare. First ask, which groups are you trying to compare on some second variable? So I got two variables, program you're in and level of concern. So one of them defines the groups I'm studying, the other is the characteristic I'm studying. So if the groups are in columns, then you're looking at percentage of column total. If the groups are in the rows, then it's percentage of row total. And your charts are going to look different. So let's look at one that's maybe easier. Let's look at program and gender. And here I can come up with maybe better questions back and forth. So let me get rid of this. And I'm going to pick gender. Where is it? Here it is. All right. And I'm going to get rid of the blanks. Okay. So here I've got a table and I've got a chart, and I'm going to put my chart here. I'm going to make my chart a little bit smaller so I can tuck it underneath the table. So within this one, I've got 3 programs and I've got male or female. In this one, I'm looking at a particular question. It says, within arts, what percentage of students are female? So I've got it adding up to 100% here for arts, and students are female or they're male, that 3/4 of art students are female. Okay, that's what it's giving. Within business, it's close to a 50-50 split. It had female at 54%, male at about 46%. And if I look at science, it's more like a 60-40 split. In each instance, you'll notice that about 2/3 of our students, of our student body, are female, but 1/3 are male. That's actually not fitting the student body in 2010 when the survey was done. We just had a higher response rate from females in the survey. Overall, the university was close to a 50-50 split in that year between male and female, but women were more likely to respond to the survey. But that's beside the point. But it is something important when you're trying to generalize to the student population as a whole. But this is telling me that that if I know the student is an arts student, the student is likely to be female. If the student is a business student that I've got, it's almost split between male and female. When I'm, it's not, if I flip it around and change things, rows and columns, what's it telling me? Okay, this one here, okay, is one where this is among all the females. I'm still looking at percentage of column total. If I'm looking at all the females, and of the females, about half of them are in arts, about a third are in business, and about 1/6 or so are in science. If I'm looking at the males, about half of them are in business, 30% in arts and 20% in science. So here I'm looking at gender and how are they split across the faculties. Whereas in the previous one, I was looking at the programs and looking at what the gender split is within each program. They're different questions. In this one, the group is program, and in this one, the group is gender. And so both cases, it's percentage of column total. If I flip it around and change it to percentage of row total, I haven't flipped anything. Okay, this gets tricky with my picture. Okay, so I'm looking at arts compared to business compared to science. And I'm looking at the gender split. So this is the same table I had earlier, but I've flipped it on its diagonal. Okay, it's the same numbers. Remember the 75, 25, and so on. But if you look at your picture, it's a little bit different. It's actually probably a better picture than I had previously. In this one, it says arts, male versus or female versus male, business, female versus male, science, female versus male. So it's looking at this cluster and how it splits, this cluster, how it splits, this cluster, how it splits. The default chart that you're going to get with Excel and a pivot table is a column chart. And it's going to have certain clusters on the horizontal axis, and then the other variable as being this legend that's over here. And it always picks the rows as being what's on the horizontal. So the previous picture I had, okay, that I had, I'm going to flip it all around to where it was to begin with. I had it flipped like this, and I had percentage of column total. Okay, these were the same numbers. So I've just flipped the table, and I think for those two tables that I had, this one or the other one, interpretation of them is straightforward. It's the same way with both tables in terms of trying to read it. But the pictures look different. See, in this picture, it's clustered the females all together. And I'm saying in art, 75% female, business, 50% female, science, 60% female. Is that what you want to compare? Um, it's a different picture than I had before. So this one is clustering around gender and looking at the program. This sort of structure probably isn't what I want to see. It's not, this type of structure might work if I wanted to do a different percentage. Let me do, generally with the charts, it's percentage of row total that you're wanting to study, if that's the way you're structuring it. So females, 50% in arts, 35% in business, and 16% in science. So this is of females, how are they split across the three programs? Of the males, here how they're split across the three programs. So if my cluster is gender, I'm probably looking at what's the pattern across programs. And then of males, the pattern across programs. In that instance, then, I'm going to have to put the cluster I want to look at on the horizontal, and then the other thing on the vertical. It's tricky as to how you want to flip it around, but the different configurations give you different interpretations. That it's trying to understand what the question is. What am I saying in the slides? Maybe I've confused you all now. So these were frequencies, which don't tell me anything. So this was putting it as percentage of column total. For each program, what percentage are male and female? But the chart that's here, I'm not sure if that's helpful, because I'm probably looking at comparing this blue to that blue, this orange to that orange, this gray to that gray. I don't want to have to go from cluster to cluster. Why not just put the two gray columns together, the two orange ones and the two blue ones, which would mean flipping my table. See, here we are. It's flipped. All the arts together, the business together, the science together, and then looking at how the percentages vary between the two genders. The table interpretation stays the same. That it's just how to do this in a visual fashion. So for visual learners, data presentation is sometimes a little more complicated than it is for those that like tables and numbers. If you're using a visual tool, more care has to go in to the design of that visual tool. The If you were looking at it in this fashion, so I'm comparing how females are spread across programs, this how females are spread across, or how males are spread across programs. Again, I've got it the wrong way flipped around. That if I'm comparing males and females, I need to put them on the horizontal and the other on the vertical, and I'll probably need to again do percentage of row total. So I flipped it this way, and then it's easier to see, oh, that in females definitely tend towards arts, and males much more towards business. And it it's challenging, okay? Again, this one just as an aside. This data set, it's from a survey. It's an observational study, so it's only those that responded to the study. And are the differences I'm seeing in gender breakdown because females are more likely to respond to surveys than males are? I don't know if art students are more or less likely to respond to surveys than arts or business students are, but maybe the differences I'm seeing are due to different types of response rates than it is to real differences in those groups. Tricky thing within surveys. So if you know in advance certain characteristics of the population, and this one before the survey was done, we knew in terms of invitations that were sent out, how many males and females were invites sent to, how many arts, business, science students were invites sent to. So we have this data, the correct data in the administrative database. And I could look at, does the survey picture look like the real picture? And they actually don't. They don't match really well. But I got a lot of data here. I'd like to use it. In this instance, what they did was they weighted the responses. And so instead of counting each female as one and male as one, they were counting each female as 0.79 and each male as 1.38. And they did other types of fudging in it, way beyond the scope of this course. But sometimes we can try to repair the damage of our observational study and problems with response rates if we've got appropriate benchmark data to do some readjustment with on some of those variables. That I can also break it down by even more variables if I want to. So here's a really messy one. So I took gender and program. So let me put you over here. And so females across programs, males across programs. Let me start out by put no calculation for the moment. And then look at the response to, say, a question. Since I've got it by what program they're in, let's look at finding a job in your major. And we're going to get a whole bunch of little frequency counts. And that if I'm looking at level of concern as the pattern of level of concern going across, let me go and make this percentage of row total. Yeek. And I'm going to close this guy out so I can see what's here. I don't like this. Let me just, very, very, very busy. You can get rid of those two. I don't want. Let me move things around. Let me move this guy way over. Oh, there it is. Okay, now they're in order, but they're way too busy for me. So this is the pattern among female art students. This is pattern among female business students, female science. Maybe too many columns. You could, I guess, go and um, group these and let me collapse it down and collapse that one. And I'll take these last ones. I've got to make it something manageable for me to understand here. Um, collapse, collapse. This is just, as you can see, getting complicated. And I'm going to group these ones together. And I'm just going to call it concerned. That's it. Okay. So now at least it makes it easier for me to do some sorts of comparisons and look at um, the level of concern by gender and by program. Really, really busy looking. It may be a little bit difficult to see, is there anything really important within this? And this is one where I've collapsed it down as much as I can, but notice how many groups I've got. I've split it down to 1, 2, 3, by 6, 18 different groups. And so I've carved up my data in quite a granular fashion. Not a big pattern in here, but you may want to go back and check, see, did I grind it up too much? Whoa, look how small these groups are. So not concerned at all. There's, yeah, maybe a fair number of values, but in these ones here, they're very, very tiny. So these are tiny, tiny samples in the neutral category, probably not telling me anything at all. And these are relatively small samples, even in the concern category. It looks like, notice I'm down to 588 values here because I've trimmed out things that didn't fit. So just in the filtering, I've lost a whole bunch. And then of the 588, I split it into 18 little boxes. And since most of them were not concerned, that they're way over on that side, any of those percentages I just had are very, very inaccurate, except for maybe this group. These ones might be reasonably accurate, but these ones are pretty poor. So be cautious in interpreting and trying to do anything. We can look at 3 variables at once, but it's really hard to do. That there's just, it's too busy. Most of us can only handle comparing 2 things at once. We can't handle 3-way comparisons. Um, it we can't wrap our head around it. Even if we could see it clearly, it's hard to wrap your head around. So just because you can do it doesn't necessarily mean it's a good idea. Um, that and we can rearrange things. Before I had it first by gender and then by program. Here's it by program and then within program by gender. It's still, I don't know, it's too much. It's making these charts and tables are really easy. It's not hard to do. I can make really attractive looking charts. Some of these look visually appealing, even if we can't understand them. Um, if you've got a report with a lot of text in it, um, you get bored. You just want to skip it. Most of us don't read text, but we like looking at pictures. Look at if you're on a website, if you're reading a magazine, paper type, what do you look at? You look at the pictures and you look at the headlines. You don't read the text. Very few people do. In your economics text, do you actually read it all? It's heavy reading. might look at pictures and you'll pay attention maybe to the headings. So try to make it informative and so on, but then it's what are you trying to say? The important thing is figuring out what the question is. Put more time into defining the question than to actually answering it. That what are you really trying to look for in here? Are you trying to compare males and females? Fine. Structure pictures where it says this is the picture for females, this is the picture for males. That are you looking for a specific pattern? If you found a pattern, write out what the story is. What's the key finding that you've got in it? That's the title to your picture. And then make sure your picture answers that as clearly as possible. So flipping, is it rows, columns, percentage of row, percentage of columns? Do I cluster? Which things do I cluster around? That we didn't find much in the way of patterns here, but if we did, we want to have a story that's got impact, a visual that has impact. And if you do a good job, then you will get that type of thing. As I said before, watch it. The smaller you get, the smaller the samples. If you're trying to get a sense of what's the error in these, uh, when we looked at averages a couple classes back, I talked about standard error. What does that mean? It's a measure of how accurate an average is, like we were looking at average salary. And how far off do I think my estimate of the average is? If I'm saying the average is 50,000, I know it's not exactly 50, but could it, the actual average be as low as 45? And I might say, no, I think maybe 47, maybe up to 53. But with my data, it was probably the average salary students expected was between 47 and 53. So I'm qualifying my answer by saying it's not perfect. It's got a margin of error in it. So what would be a margin of error in a percentage? Generally depends upon the sample size. And these are just a rough rule of thumb. Your sample size is only 50. Don't be surprised if your margin of error is 7 percentage points. So if you said 35% of students, of female students were in business, well, maybe it's not 35, maybe it's 28, maybe it's 42. That's quite a range. And that's a sample of 50. Even if you've got a sample of 1,000, don't be surprised if your margin of error is actually about double the standard error. So if you hear of an opinion poll and they say that the margin of error in this opinion poll is plus or minus 4 percentage points 19 times out of 20, they're giving you a margin of error of around plus or minus 4 points. The 19 times out of 20, when you get to a stats course, they'll tell you what that means. But it's giving you an idea of how much should you read into this. So with opinion polls, where we get a margin of error generally around 3 percentage points if there are 1,000 people in it, sometimes a little bit less. If I've got a poll that said if an election was held tomorrow, what percentage of people would vote for the Liberal Party, and the poll done in the fall was 44%, and the poll done last week was 46%. You say, oh, support's increasing? No, it went up by 2 points, but the margin of error is about 3 points. So it could well be that it's just the survey. If we did another survey, we might find it's down to 42%. Not that attitudes have changed, it's just the who gets into the sample. That's my margin of error. So to recap, these pivot tables, I can do all kinds of really neat things in looking for patterns. Most reports of a data set, the key findings can be summarized by just using a pivot table on your data set. You don't need to do very fancy technical analyses. We're going to get into more advanced models, but most of the time you get the key answers, key findings come out of just looking at averages and percentages in the appropriate fashion, making sure you've got the right questions, and done with a pivot table or better with a pivot chart. And that your final report to your client in 90% of the time can be just what we've done up to today. It's going to be enough for you to write a high quality report for a client. You don't need to get into advanced data mining tools. But if you do, you can get into more complex types of analyses, particularly if we want to get into making predictions. So far, all we've been doing here are just showing patterns, but we're not making predictions out of the pattern. But if I'm just trying to summarize patterns, what you've seen with these pivot tables and pivot charts, you can do it. And they look easy. If you play with it, it seems, I enjoy it. It's fun. I can do these, change things around quickly and easily. The hard thing is figuring out what's the right question to ask. And that making sure I'm measuring things the right way, the percentage of row total, percentage of column total. And I get carried away with my data set, and I like to drill in, looking deeper and deeper for patterns, and I get into these small sample problems. So I have to back up again and check to make sure I've not led myself astray, because you can get very absorbed in it if you're like me and like playing with numbers. That what I want to get into next is looking at relationships, and then we're going to take relationships to use to make predictions. And the one device for doing that is sort of like looking at a series of histograms, which is confusing to do. So I'm going to show you a very crude tool. Goes back to the 1970s, called a box and whisker chart. It's one of the few things we'll do in the course that I'm going to have you do it by hand, because there's almost no arithmetic in it. And there's some simple multiplication and some simple addition or subtraction. But it's a better tool than using empirical rule to getting a good sense of high, middle, and low. And in the class after that, we're going to look at trying to go and move to looking at purely numeric data and finding patterns within it. And this box and whisker chart has certain value even in that context, although a lot of people don't use it. I find it attractive in keeping things relatively simple and not getting distracted by detail that doesn't need to be there. But we'll get into the stuff afterwards. And I think I'm at the end of my story for today. Yeah, finished on time. So we'll leave it for today. Next class, we'll get into chapter 5. I've just added a couple videos into chapter 5. I don't have videos for all the future chapters, so I'll try to get them added in as we go to show you how to do these things. And with the box and whisker, it's how to do it manually and how to do it with Excel, and then how to do other types of charts in Excel we'll get into. And after chapter 5, we hit the heavy stuff of value estimation, building actual models and doing predictive modeling. And we'll be doing predictive modeling through much of the rest of the course. That chapter 5 is probably the last one that we're doing that is, I view as being exploratory, exploring my data. Chapter 6, we get into actual model building. And there's some fun stuff in that too. Okay, take care. And I will be following Catherine. I see your chat still there, but got class right after this one, but I'll be following up with you later today. I'll take a look at your assignment, and we can have a discussion further. And with others that have issues with the assignment, we'll take that up after. Take care. Bye now.